In this video, we're going to look at topic 87, example 4, subtract rational expressions. So what is the difference between the quantity x plus 1 over the quantity x squared minus 6x minus 16 and the quantity x plus 1 over the quantity x squared plus 6x plus 8? So let's get started on this and let's turn this into a subtraction problem. I'm going to factor the denominators right away. So x squared minus 6x minus 16. We're looking for factors of negative 16 that have a sum of negative 6. So 1 and 16, 2 and 8, 4 and 4 are possible combinations. Let's fix that. We need a negative. So 2 and negative 8 would give us negative 6. So this will factor into x plus 2 and x minus 8. Again, you should be getting quite good at factoring, especially factor sum by now. So some of you will be able to skip that factor sum chart. And then we're going to subtract our second rational expression, which is x plus 1 over. Now we need factors of 8 that add up to 6. I'm going to skip the factor sum chart here. This one is pretty straightforward. 2 times 4 is 8. 2 plus 4 is 6. All right, so step 1, factoring is out of the way. Now we're going to look for our common denominator. So common denominator, I'm going to take all of the terms from the first fraction. So I'm taking the x plus 2 and the x minus 8. And then the second fraction, or rational expression, I have an x plus 2, which I've already accounted for, and I have an x plus 4. Okay, so I'm going to put that x plus 4 there in the denominator. So that would be my like denominator or common denominator. So I'm just going to repeat that for the second expression. So once again, you're looking for all the parts from each one that will give you a common denominator. Now my first numerator was x plus 1. In the denominator, the x plus 2 was already there, the x minus 8 was already there, but the x plus 4 is new. So since it's new in the denominator, I need to also include it in the numerator. Remember, new terms need to be included. For the second expression, again, the x plus 1 was already there, so we keep that. The x plus 2 was already there. The x minus 8 is new, so I'm going to include an x minus 8 in the numerator. The x plus 4 was already there, so I don't need to worry about that. So I've made my changes to have a common denominator and then made the appropriate changes to the numerator, or the appropriate additions to the numerator. From here, we want to look to start distributing within the numerator, and then eventually we're going to actually combine these fractions. So I'm going to take my numerator and distribute the x and the 1. So we get x squared plus 4x plus 1x plus 4. And that's all going to be over my common denominator. And I'm going to do the same thing for the right side. Distribute. I get x squared minus 8x plus 1x minus 8. And again, write our common denominator out. All right, I'm now going to move this up here. I'm going to combine like terms. So x squared plus 5x plus 4 over x plus 2, x minus 8, and x plus 4. Once I have my common denominator, it's going to stay pretty similar until the end, where I need to look to see if I can reduce anything. It does get a little repetitive because we have to write the same common denominator over and over again. My second expression, my numerator, x squared minus 7x minus 8. Just check your work, make sure that everything makes sense, make sure you've been combining correctly, so we're good. All right, now, the next thing we want to be extra careful of is that we need to remember that this subtraction sign here applies to the entire numerator. So you need to think of it almost like distribution. So I'm going to combine these two fractions, and I'm going to do x squared plus 5x plus 4 minus x squared minus negative 7x, so that's going to become positive, and then minus negative 8, so that would also become a positive 8. My denominator stays the same. Okay, so remember that these three terms here came from distributing that subtraction sign or that negative sign. Now we look to combine like terms. X squared minus x squared, that cancels out. 5x plus 7x would be 12x, and positive 4 and positive 8 would be a positive 12. Copy our denominator for what feels like the 100th time. Check your numerator, see if you can factor anything. In this case, we do have a GCF, a greatest common factor of 12, and we would be left with x plus 1. Copy the denominator for the 101st time, and then just check to see if you can cancel anything out. In this particular problem, there's nothing that can be eliminated from both the numerator and the denominator, so we are done combining using the difference, right? The difference of the rational expressions. You do need to always factor at the end to make sure nothing can be eliminated or reduced. Now, the only thing we have left is we should state our domain. So the domain is going to be all real numbers except x equals negative 2, which I get from my like denominator or common denominator, positive 8. I'm not going to worry too much about these being in any specific order, and negative 4. All right, as long as you have them listed, that'll be good enough. Same thing with the denominator, our final denominator here. Maybe there's a better way to organize those, but as long as all of the terms are there, we're fine. All right, so we don't have to worry about putting them in any type of numerical order. You'll see that subtraction problems are very similar to the addition of rational expressions that we did in the previous video. The major difference being what we have highlighted in green over on this right side. You need to be careful when you're subtracting. That subtraction sign applies to the entire numerator for that, in this case, that second expression. Right, so be very careful with the subtraction sign, but all other things are pretty much done the exact same way.